Okay. So remember, guys, to write this in standard form, this is an equation of a circle. And so it is not in standard form. If I want to know what is the center, what is radius, can't really tell it in this format. So what I'm going to do is I'm going to graph all, I'm going to do complete square to find the standard form. And so I'm going to group my x together. That gives me x squared plus 6x plus a little space right there, plus the y squared minus 4y, little blank, and then I'm move the constant to the other side. That gives me 3. Okay, now with complete square, I'm going to find the b value. I'm going to take the b value here, which is 6, and divide it by 2. Okay, so 6 divided by 2 is 3. If I'm going to have an x plus 3 squared here. That's 3 now. I'm going to square it. That gives me 9. So I'm going to put a 9 on the other side. Good. All right, go to the y's now. My b value is -4. -4 divided by 2 is -2. So I can give me a -2 right there. And I'm going to square -2. That gives me a +4. Okay. I'm also add a 4 on the other side. So when I add these numbers up now, that gives me 16. That's the answer right. All right. Okay. You must know this. You must know this. You must know to do complete square. Because the next fourth section is going to involve this right here, complete square. All right. So let's jump into ellipses real quick. 15. Well, I clean this up. All right. Ellipses. Again, if you take a circle, all right, you take a circle and you squeeze it down, all right, it's going to look something like this, all right, where the horizontal axis is going to be longer. It's going to be longer than the vertical axis, right? And so that gives some ellipse. This is the mathematical definition of an ellipse. All right, and ellipse is a locus of points. The locus, I could say like maybe the set of points. Another word we're putting it. So you have an ellipse, right? All these points on the ellipse, right? All right, these are the points. You take any 2 points on the ellipse, such that the sum of the distance from any point on the ellipse. So if you take any point on the ellipse and you draw the distance to the focus. All right. These 2 distances, when you add them, will be the same for any other points around the circle. Doesn't matter which point you take. You can have a point right here and you draw the distance from that focus right there and that focus right there. If you add the distance here, it's the same as you add those 2 distances. Okay. Yes, geometry. These 6 points are called focus, foci of the ellipse. Right? And the distance b1 plus b2 remains constant, right? For all points on the grid. Foci, F-O-C-I. F-O-C-I. B1 plus B2. Right? Set. Another word for locus, another word for set. Set. S-E-T. Set. All right. Here we go. And so now, here are 2 ellipses, a horizontal ellipse, you can see, because this axis is longer, right? Yeah. And this is a vertical ellipse, that axis is longer. Okay. The longer axis is we call it the major axis. That is a major axis, all right? This is also your major axis, okay? Yes. The shorter axis, that must be funny right here. The shorter axis is your minor axis. Minor axis, M-I-N-O, minor, okay? So this is also your minor axis. Good? Major. No, real quick. That's a major axis, and that is a minor axis. No, not a word down. Okay? Yeah, the longer one. Okay? All right, so definition of major axis, that is your longer axis. The minor is your shorter axis. Okay, your center, of course, HK. We all know what the center is, HK. Okay, vertices now. What are vertices? Let's go by this diagram right here. Vertices are the endpoints of the major axis. So here is my major axis. All right, that's my major axis. The endpoints of that axis is called the vertices. For the minor axis, the endpoints are called co-vertices. All right, good so far, all right? So vertices, all right? Vertices are the endpoints. Endpoints of major axes. Okay? And co-vertices are endpoints. Endpoints of minor axes. Huh? Huh?
He's begging for the installer.
Oh, young. Oh. Okay, and got it? This is far. All right, good. All right. So now let's jump over here real quick again. Now I'm going to give you the equation, the formula for the ellipses. Right? So for the horizontal ellipse, right? The equation is this: x squared. I'm sorry, x minus h squared plus y minus k squared. That looks familiar, right? Let's see it before, right? Over is a minor difference now. Over a squared over b squared, and that's equal to 1. So I'm going to give you both equations and ask you what's the difference between them. So that is the equation for the horizontal ellipse. Yes, a squared, a squared, a
So
squared.
is the vertical plus x plus h?
Where's it? Plus h.
For the vertical ellipse?
No.
Or is it the same?
Same equation, but there's a minor difference. Here we go. For the vertical, it's going to be x minus h squared plus y minus k squared over b squared over a squared equals to 1. What's the difference?
Let's switch
The a's and b's switch, right? Good. Okay, the a squared number, this number for the a squared is a bigger number. So the bigger number goes under the major axis, right? So the bigger number is on the x, that means it's horizontal. If the bigger number is under the y, it's vertical ellipse. So the a squared is always a bigger number. Yes, sir.
The number of the major axis on the y side.
Yes, because that's a bigger number. Okay, we're gonna do some examples in a second. All right. All right. Now, the length of the major axis, right? You get it here. The length is a. That's a. Okay. And then the minor side now, this length is B. So its length is 2A, and the total length is 2B. For the vertical now, this here is going to be what? A, exactly. This is going to be A right here. Looks different color. That's gonna be A right here and A right there. And then that's gonna be your B value here. Good. So for the vertices now, right? They are A units away. They are plus and minus A units away from the center. A right here. Co-vertices, they are plus and minus B units away from the center. All right. So B units away from the center for the co-vertices. Good. Now the foci. Now let me go back and read something right. These dots right here are your focus. This is the focus right here.
Major.
Yes, those dots right here, they're called focus. You're always on the major axis. You're always on the major axis. So here, this is horizontal. You're right here. Vertical, you're always on the major axis. Right? Huh? No, these are the endpoints. Those are the vertices.
Oh.
Right. This right here, these are your focus. Okay. And focus, right? Again, the focus are always on the major axis. And I said they're always on the major, axis. Good. And they are plus and minus C units away from the center. Now, how do we find the focus? How do we find the length of the focus? All right. Well, there's a formula for that. The formula for the focus is C squared is equal to A squared minus B squared. So you take the A squared, all right? A squared minus B squared gives you C squared. That's what we find. All right, we're going to do an example and you see how everything comes into play. Again, the formula for horizontal, I gave that already. Horizontal, the H right here. That's just X minus H squared plus Y minus K squared. And that's over A squared over B squared. And that's equal to 1. For vertical now, because B for vertical, okay? That's going to be X minus H squared over B squared plus Y minus K squared over A squared, and that's equal to 1. Okay. All right. At this time, we're going to graph a graph an ellipse and find the vertices, co-vertices, and foci. All right, here we go. Yeah. Sure.
So the Bornholm's ellipsis diagram, this is what the standard one would look like if we wanted to graph.
Right. Good. All right. Let's try an example real quick. Here we go. Okay, when we graph these things, first thing you want to do is make sure the equation is in standard form. These are in standard form. All right, so we don't have to worry about it. But sometimes it's not given in standard form, so they're right in standard form. All right, next we're going to find the center. All right, find the center. Then we're going to find the A and the B value. That will help us find the vertices and co-vertices. So we got to find the A value and the B value. And that will help us find the vertices and co-vertices. And then we find our foci. Okay? Here we go. Let's look at the first one. Okay, what is my center? HK. Number 1. What's my center going to be? Zero. Right. There's one H and K values. So the center is 0, 0. Okay, that's my center. Good. All right. Next, I'm going to find my A value. Is that a horizontal or vertical ellipse? Say again. Why is that? The bigger number is under the X, right? So that's going to be a horizontal. That's the bigger number is under X. So it's going to look like a horizontal image. Right? All right. That 64 is a square. A square. Now, a square is equal to 64. All right. This implies that a is equal to what? Good. Right? B squared is equal to 25. Exactly. This implies that B is equal to 5. This is what the arrow means. This implies. That's what it means. This implies. All right. So now we have our B, A and B. Okay. My center is an origin. So that's my center right there. Good. Now let's go back and look at this thing right here. Remember this? All right. Remember the vertex, right, is 8 units from the center. That's the distance A from the right and from the left. So if I go back to the graph now to find the end of the vertex, right? Exactly. I'm going to go 8 units from the center. 1, 2, 3, 4, 5, 6, 7, 8. And on the other side, I go 1, 2, 3, 4, 5, 6, 7, 8. Good. So what is the coordinate of those 2 points? 8, 0, and so therefore my vertices now, this is going to be 8, 0, and this one is negative 8, 0. Everybody see that? Okay, 0. Okay, so it's going to be 8, 0, and negative 8, 0. Good? All right. Okay, let's find out our minor. Exactly. All right. My co-vertices now, I'm going to go up 5. 1, 2, 3, 4, 5, and down 5. 1, 2, 3, 4, 5. What are my coordinates for those points?
0, 0, 5.
Exactly. So my co-vertices now are 0, 5, 0, 5, and 0, negative 5. Good? All right. Let's go ahead and skip graph now. All right, so that's ooh. What is that? That's a 2K. All right. Good so far? Yes, sir. Go ahead. All right. The next thing we're gonna find out is our foci. All right. All right. The formula for the foci is exactly C squared is equal to A squared minus B squared, right? A squared minus B squared. My A squared is 64 minus 25. And so that's C squared, therefore C is going to equal to now the square root of that. What is 64 minus 25? 39, right? Right? 5 from 9, 2 from 5, 39. What's for 39? Roughly 6 times 6 is 36. So I want to say around 6.2. Yes.
Yeah.
Yes, we do. Six point two four five. 6.245. Then 6.2.
Minus B squared.
Down the 4, the 5 is the 4.
What was it? 6.1?
You think 5?
6.45?
Yeah. When that is round these. Come on, doing 6.24 now.
6.24. That's the 6.2.
Right.
So that gives me 6.2. Everybody see that? 6.2. 6.245. I wrote one decimal place it is. 6.2. The 4 is smaller than 5. One decimal place. Right here. So I go to the next number. Four is less than 5, so we keep that 6.2. If this was 5, 4 now, then because 5 grid is 5 grid now, and
I mean, that was good just round to 5.
no, I want one decimal place to be pointed. All right. Now, so remember now, look at this right here now. The focus now. The focus now is always on the major axis, right? It is C units from the center. That's C units and that's C units. Good. Just like the vertices, we went 8 units to the right. Was it 8? Yeah, yeah. The foci now, we go 6.2 units to the right and 6.2 units to the right. So here we go. So let's go 6.2 units now. Here we go. 6.2 units to the right. 1, 2, 3, 4, 5, 6. So 6.2 is just a little bit off to the right. Okay, got 6.2 right there. And then 1, 2, 3, 4, 5, 6. So 6.2 is somewhere around there. You're gonna guess a little bit off, but you get the picture. Here. Everybody see that? So what is the coordinate now of the foci? What is the coordinates? 6.2, 0 and negatives. Everybody see that? No? It's on the x-axis, it says to the right, so it's going to be 6.2, 0, and this one to the left is going to be negative 6.2, 0. Questions? All right. Okay, let's try the next one on your. I want you to try this one on your own now. I want you to start it. All right. Find your center. Get your A and B valid. It's going to be a horizontal or vertical. Got it? So it's gonna be 6, 5, 4, and 5, negative 8. Find the post. Yes, I'm always A value. Let's go. Yeah, okay, good. Okay, my center is gonna be.
Oh, where did you get 6 from?
Oh, you know what?
Don't even, don't even.
Good. Okay. My A, what's my A gonna be? B is. Okay, so let's talk my points now. 5, negative 2. 1, 2, 3, 4, 5, down 2. That is my center right there. HK. Good. Right. My vertices now. Now, is this gonna be a horizontal or vertical ellipse? Vertical, right? So for the 6 now, I'm going 6 units up from the center. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay. And then 6 down. 1, 2, 3. Good so far? Good. All right. And then for the poke vertices now, I'm going to count about 3 units to the right. 1, 2, 3. 1, 2. Pause. Any questions? I'm pausing right now. I see a head shaking now. No questions. Got it? All right. Okay, so let's put the coordinates out. My vertices for number homework. We're not gonna finish this one. So it's number 4. Probably gonna do 3 and 4 for homework. All right, and then I give you an extra day for that sheet I get you. All right. So my vertices now. What are my vertices? Somebody real quick. 5, 4, and 5, -8. Questions? And that one. 5, is that correct? Minus, yes. Yes. Questions? Right. Co-vertices, what do we have? 2,82, right? I can just look at the graph and see what's the coordinate for those points are. 2, and is it 8? Oh, it's 3, I'm sorry, it's 3, right? Yeah. 8,82. Okay, let's find the both sides now. Okay, we're going to use the formula c squared. I would say c is equal to the square root of 36 minus 9.
You get 27, and then you get 5.196, and you 5.2.
5.2, which is equal to roughly equal to 5.2. So therefore, I'm going to count off 5.2 up and 5.2 down. Okay, 5.2 up. 1, 2, 3. 1, 2, 3, 4, 5. So 5.2 is just inside right there. And then 1, 2, 3, 4, 5, just inside there, right? Okay. And so now if we clean this up a little bit. Okay. What is the coordinate of those green points? 5 and 1, 2. Is it 3.2, right? Is it 3.2? No. Okay, we went up with a 5.2. Yeah. So this is 1, 2, 3. All right. So it's 3.2. Everybody else got 3.2? Okay. So this is 5, 3.2. And then we go down now. All right. This is 2, 3, 4, 5, 6, 7. 7.2. So it's going to be 5, negative 7.2. Okay. All right. So we didn't finish 3 and 4. All right. So we're going to finish 3 and 4. And then that sheet that was due today. All right. It's due tomorrow. Are we good? Oh, so we got 30 ready. That's due tomorrow. Okay, got it. Calculus, please, calculators.